Okay, so we're next going to use reference angles and reference triangles to evaluate trig functions. So there's a 5-step process that you guys want uh, to use reference angles to evaluate trig functions. So step 1 is to make sure that your angle is between 0 degrees and 360 degrees, or if we're talking about radian measure, between 0 and 2 pi. If it isn't, then you need to find an angle that is coterminal that is. So we need to add or subtract multiples of 360 or multiples of 2 pi to do so. Step 2 is to find the reference angle. Step 3 is to determine what quadrant your angle lies in. Step 4 is to evaluate your trig function at the reference angle. And then lastly, step 5 is to use the angle's quadrant to determine if the ratio is positive or negative. Okay, so let's get into some examples involving this. So again, I'm going to do all of these in radian measure. So anytime you're doing problems like this, you want to have the two reference triangles somewhere on your page because you're going to refer to them constantly. Okay, so I'm going to do this. This is going to be the 30, 60, 90 triangle in radian measures. So 30 degrees is pi over 6. 60 degrees is pi over 3. So this is 1, rad 3, and 2. And then the 45, 45, 90 triangle, 45 degrees is pi over 4. So that's pi over 4, pi over 4, and the right angle. And the side lengths are 1, 1, and rad 2 respectively. Okay, so let's take a look at the first one, the tangent of 5 pi over 4. Um, so step 1, is that angle between 0 and 2 pi? Yeah, 5 pi over 4 is between 0 and 8 pi over 4. So that checks out. Step 2 is we want to determine our reference angle. So the reference angle here, because this has a denominator of 4, is going to be pi over 4. Step 3 is we want to figure out what quadrant 5 pi over 4 lies in. So we can get 5 pi over 4 by taking pi plus the reference angle pi over 4. So because pi plus the reference angle pi over 4 gives us 5 pi over 4, that tells us that the angle lies in quadrant 3. Okay, step 4 is we evaluate our trig function at the reference angle. So we want to figure out the tangent of pi over 4. So we go to the 45, 45, 90 triangle. Tangent is opposite over adjacent, which is 1. And then on to step 5, the tangent of 5 pi over 4 has that same ratio of 1. And then we use the quadrant that the angle lies in to determine whether that ratio is positive or negative. And in quadrant 3, all students take tangent is positive in quadrant 3. Okay, let's do the same thing for number 2. So for number 2, we have the cotangent of 4 pi over 3. Again, 4 pi over 3 is between 0 and 2 pi. So step 1 is good. Step 2, we want to determine the reference angle, which is pi over 3, because that has a denominator of 3. Thirdly, we want to determine what quadrant that lies in. So 4 pi over 3, it doesn't lie in quadrant 1, because the angle would be the reference angle pi over 3. It doesn't lie in quadrant 2, because the angle in quadrant 2 with reference angle pi over 3 would be pi minus pi over 3, which is 2 pi over 3. It doesn't lie in quadrant 4, because the angle in quadrant 4 with reference angle pi over 3 would be 2 pi minus pi over 3, which is 5 pi over 3. It lies in quadrant 3 again, because the angle in quadrant 3 with reference angle pi over 3 is pi plus the reference angle pi over 3. Okay, so that takes care of step 3. Step 4, we evaluate our trig function at the reference angle. So the cotangent of pi over 3 is going to be adjacent over opposite. So that's 1 over rad 3, which rationalizes to rad 3 over 3. And then the cotangent of 4 pi over 3 has that same ratio. We know that cotangent is positive in quadrant 3. Okay, I want you guys to try numbers 3 through 6 using the same technique. Go ahead and pause the video now and then start it up once you've completed those next 4 problems. Okay, let's go ahead and try problems 3 through 6. So cosecant of 7 pi over 6, again, 7 pi over 6 is between 0 and 2 pi, so we're good. We determine the reference angle next, which is pi over 6. We know that 7 pi over 6 is pi plus the reference angle. So again, that angle lies in quadrant 3. We evaluate the trig function at the reference angle. So cosecant of pi over 6, we go to the angle pi over 6. Cosecant is hypotenuse over opposite, which is 2. So the cosecant of 7 pi over 6 has that same ratio. We know that cosecant is negative in quadrant 3. Again, all students take, only tangent and cotangent are positive in quadrant 3. Okay, for number 4, sine of 23 pi over 6. That's not between 0 and 2 pi, so we have to find an angle that is coterminal, that is. So if I subtract 2 pi, this becomes the sine of 23 pi over 6 minus 12 pi over 6, which is 11 pi over 6, and that now is between 0 and 2 pi. So our reference angle here is pi over 6. We know 11 pi over 6 is in quadrant 4 because for our angle to be in quadrant 4, it has to be 2 pi minus the reference angle. And 2 pi minus the reference angle pi over 6 is 11 pi over 6. So the angle's in quadrant 4. We evaluate the trig function at the reference angle pi over 6. So we go to our diagram. The sine of pi over 6 is opposite over hypotenuse, which is 1/2. So the sine of 23 pi over 6 has that same ratio, 1/2. All students take calculus. Only cosine and its reciprocal secant are positive in quadrant 4. So that's going to be negative 1/2. Cosine of negative 3 pi over 4, again, is not between 0 and 2 pi. So I'm going to add 2 pi, which is like adding 8 pi over 4, which makes the cosine of 5 pi over 4. The reference angle is pi over 4. We get 5 pi over 4 by taking pi plus the reference angle, so that puts our angle into quadrant 3. So we evaluate the cosine at pi over 4, which is 1 over rad 2, which rationalizes to rad 2 over 2. So the cosine of negative 3 pi over 4 has that same ratio. We know in quadrant 3 cosine is going to be negative. Okay, lastly, the secant of 11 pi over 3. Again, 11 pi over 3 is not between 0 and 2 pi. So I'm going to subtract 2 pi, which is like subtracting 6 pi over 3. So 11 pi over 3 minus 6 pi over 3 is 5 pi over 3. Our reference angle is pi over 3. We know 5 pi over 3 lies in quadrant 4 because 5 pi over 3 is 2 pi minus the reference angle. So 2 pi minus pi over 3 is 5 pi over 3, so our angle lies in quadrant 4. We evaluate secant at the reference angle pi over 3. So we go to pi over 3, secant is hypotenuse over adjacent, which is 2. So that makes the secant of 11 pi over 3 have that same ratio. We know that secant is positive in quadrant 4. So that ratio is going to be 2. Okay, let's kind of work through the process backwards for these last 3 examples. Okay, so rather than finding the ratio that corresponds to a trig function at some angle measure, This time we're going to be given the trig function at some angle measure is equal to a ratio. We want to find the angles that are solutions to this equation. Okay, so we want to find the solutions on the interval from the half closed interval from 0 to 2 pi. Okay, so let's take a look at how we do this. For number 1, we have the sine of angle theta is rad 3 over 2. Okay, so what we want to do is we want to look to the triangles that we constructed here, and we want to figure out what our reference angle is going to be. So the sine of what angle is going to be rad 3 over 2? Well, if we look at the angle pi over 3, sine is opposite over hypotenuse. That is rad 3 over 2. So that tells me that my reference angle is pi over 3. Okay, what we have to figure out now is we have to figure out what quadrant our angles are going to lie in. Okay, so if sine is positive rad 3 over 2, we know that sine is positive in quadrant 1, all students, and it's also positive in quadrant 2. So we want to find the angles in those two quadrants that have a reference angle of pi over 3. So the angle in quadrant 1 that has a reference angle pi over 3 is just the angle itself, pi over 3. And the angle in quadrant 2 that has the reference angle of pi over 3 is going to be pi minus the reference angle, pi over 3, which gives us 2 pi over 3. Okay, I want you to use the same approach to give problems 2 and 3 a try. So go ahead and pause the video. Okay, so looking at problem 2, the cotangent of theta is equal to -1. We want to figure out the reference angle here. So when we look at the two reference triangles that we've drawn, the cotangent of what angle is going to be 1? And you should see that that angle is pi over 4, because cotangent is adjacent over opposite. Okay, so our reference angle here is pi over 4. And then we want to think to ourselves, if cotangent is negative, what two quadrants is that going to occur in? And all students take, so cotangent is going to be positive in quadrants 1 and 3, which means it has to be negative in quadrants 2 and 4. Okay, so our angle in quadrant 2 with reference angle pi over 4 will be pi minus the reference angle pi over 4, which is 3 pi over 4. The angle in quadrant 4 with reference angle pi over 4 is 2 pi minus the reference angle pi over 4, which is 7 pi over 4. Okay, for number 3, the secant of theta is -2 rad 3 over 3. Well, another way for me to write this is that would be -2 over rad 3 before I rationalize that denominator. Okay, so we want to go to the reference triangles. The secant of what angle is 2 over rad 3? Well, secant is hypotenuse over adjacent. So the reference angle there is going to be pi over 6. All right. We next want to figure out in what two quadrants is secant negative. So we know secant is positive. All students take calculus in quadrants 1 and 4. So secant has to be negative in quadrants 2 and 3. So the angle in quadrant 2 with reference angle pi over 6 would be pi minus the reference angle pi over 6, which is 5 pi over 6. And the angle in quadrant 3 with reference angle pi over 6 would be pi plus pi over 6, which would be 7 pi over 6. If you can't look at the two reference triangles that we've drawn to like match the ratio that you're given, then it's probable that your ratio is going to correspond to a quadrantal angle. So you can sometimes get solutions to this that are quadrantal angles where your solutions would be like 0, pi over 2, pi, 3 pi over 2, depending on the ratio that you're given in the problem. All right, so that'll wrap up this lesson here. Your homework assignment will be posted on Schoology. Take care.